Hi everyone, thanks for coming to my talk. Thank you to the Randomood team for having me, even though they're not in the room right now. Well, actually, I see one. My name is Kevin Charm. I'm going to be talking a little bit about the road to Anyrand VRF. I'm from Frogworks. I'll explain a little bit more about what Anyrand is. That is not... All right, these slides are off. These slides are wrong. Yeah, I'm not sure what's going on, but this is not the, I think it's missing some stuff. I have my laptop, but some stuff is out of order. What does that mean? Oh yeah, roulette. It's okay. I can just I'll just wing it, whatever. Yeah, so it's all good. So it's gonna be a little bit out of order, so it might be a little bit chaotic, but so apologies for that. Anyway, what is Anyrand? Anyrand VRF is a service that provides verifiable random numbers to any EVM network. It's powered by the new drand threshold network. It's called evmnet. It's also run by the League of Entropy. It's running on a custom scheme that we built specifically together with the Randomood team for the EVM. Let me just find the next slide to go back. Yeah, so okay, these are like super out of order and missing stuff. Okay, so this is a diagram of how it works. It's now gone. Anyway, it's just a regular. So it's just the normal way that drand works. You've got the League of Entropy threshold network, except now it can produce BLS on BN254 signatures. Yeah, and Anyrand is basically just the on-chain part that can verify that new BLS signature scheme, and then it feeds the signatures into a Ketchak so that consumers can use verifiable randomness. So why VRF? I think if you're here, you probably know like why we need VRF or why it's interesting. Blockchains are pure, so they're fully deterministic, except for user input, I guess, like transactions that add kind of entropy to the chain. We need unpredictability to build apps. So for example, games of chance. So these are like lotteries, raffles, NFT reveals, booster packs, card games. And actually, we at Frogworks, we're building a product called Lotto PGF, which is a public goods funding mechanism through lotteries, and that needs unpredictability, and that's why we were even looking at VRF in the first place. Some other things you might need VRFs for is fair distributions, so like IDOs, if you got like an oversubscribed round, like thousands of people that want to participate in a public sale, but you only have space for like 100, 200 people, how do you do that fairly? You need something like VRF. You want it to be a verifiable random number that picks, a subset of these people, so you know that nobody's, there's no insider trying to manipulate stuff. Another interesting use case would be a sortition for governance. So, for example, Kleros does something like this. They use VRFs, and yeah, so there is actually there are some on-chain sources of entropy on Ethereum mainnet. For example, like block hashes and RANDAO, they have their own problems, but importantly, they're really only available on mainnet and not like rollups. The existing VRFs, we have, Chainlink VRF, you should probably know. I hear some boos in the crowd. Unless you've been living under a rock, you probably know what that is. It requires an entropy source, so that they use a block hash, a future block hash, which is actually a problem, and that's why we actually use drand. Yeah. Okay. Thank you, Kent. All right. Where was I? Yeah, so they use block hashes. And in the next slide, I'll show you why that was a problem for us. It's also very centralized. It depends on a single operator to produce signatures so they can selectively censor you. I don't think it's ever happened, but it is a possibility. It does also need extra machinery for recording future block hashes, especially if you use a really like in the future, and then you got to do that more than 256 blocks look back. You need some extra machinery to look back past 256 blocks. There's also API 3 QRNG. This is not actually a VRF. I just put that in there just to highlight that there are some products out there that are not VRFs. This uses some sort of like noise source from some quantum computer. It doesn't really matter what it is. It's not cryptography. It's not verifiable, so it's not really interesting to us. There's also pith entropy, which is a very interesting like two-party protocol. Still depends on a single operator node to reveal pre-images. So quite centralized. And it also requires some entropy from the user. So this is the problem I was talking about. This is the scroll docs. You can see that it doesn't work exactly the same as Ethereum mainnet. The block hash opcode actually just returns a catch-ack of the chain ID concatenated with the block number. So it's completely predictable, it's completely deterministic, and there goes our low-quality entropy source. So what about drand? Well, it's decentralized, which is a good start compared to the other incumbents. That means a single node can't selectively censor the production of a new signature. And so we don't have to rely on block hashes. Now, I highlighted in red that it requires BLS 12381 operations because about 2 years ago, when I started thinking about this stuff, it was very expensive to do BLS 12381 operations in the EVM. And there's an EIP to 2537, I think. But we've been waiting for that for how many years now? Like 4 years, 5 years? Apparently it's going to be included in Pectra, but yeah, we'll see about that. Yeah, so where did it all begin? About 2 years ago, 2022, the roll-up narrative, the roll-up explosion, many new EVM roll-ups. What I found that a lot of them didn't really work exactly like Ethereum. They all had some sort of quirk. And so during ETH Denver 2022, I worked on something called RNGesus, which is like the first iteration of the VRF service on top of drand. I tried to verify BLS on BLS 12381 signatures. Back then it was still on signatures on G2 with Circom, Snark.js, the classic. Just forked Yi-Sun's Circom pairing repo to do that. Made a couple of tweaks. It wasn't practical because it took like half an hour to generate a proof. And the verification was, well, the Groth 16 was only like 250K or something, but like I had to do some other stuff on chain. Ended up being like 8 million gas or something. Anyway, it wasn't practical. I'll talk a bit about BLS on BLS 12381 because this was a source of confusion for me. I think it's a source of confusion for a lot of people. I guess there's a lot of cryptographers here, so maybe it's not a source of confusion, but there's two BLSs here. There's BLS, the signature scheme, and there's BLS, the elliptic curve family. And we are interested in the BLS signature scheme, but when I'm talking about like making changing the scheme, I'm talking about like changing the elliptic curve family, so the BLS 12381 part. Yeah, so we can't efficiently verify BLS 12381 pairings, except nowadays maybe you can do it with circuits. I think I asked a question from the previous presentation. It was like 200K, 300K gas or something like that, and 3 minutes to generate the proof. So it's more practical nowadays, but it's 3 minutes. Like that's now your lower bound of producing VRFs. However, we do have BN254 pairings, which means if we change the BLS signature scheme to use the BN254 elliptic curve, that means we can verify it efficiently in the EVM. The problem with this is it's not standardized. Like nobody uses it, right? Everybody just uses BLS 381 because it's more secure. But the thing is, like all the snarks that run on Ethereum, for example, like Tornado Cash, which secures, I don't know how much it is now, but probably at some point a few billion dollars. It uses BN254, so it's secure enough, right? Especially for VRFs, it's secure enough. I found exactly one instance of it in the wild, and it was an old EF funded project, I think. It was an old optimistic rollup called Hubble. And it used a non-standard hash to curve function based on Miracle, the cryptography library. It was a bit fiddly, but it was a good starting point for the BLS contract. Yeah, so constant time hashing to the curve is ideal. We had, I think, a lot of discussion about this, me and Yolan. And yeah, so interestingly, Chainlink VRF actually just uses hash and pray. So they just keep hashing until they find a point on the curve. And it seems to have worked for them. But yeah, we looked at the hash to curve standards in RFC 9380, which does define hash to curve mappings for BLS 381, but not for BN254, unfortunately. But they do lay out like the algorithms, the generic algorithms that we can use. And so we ended up implementing the Chalu van der Woestijnen constant time mapping for G1. It's more gas efficient than the Fuchs-Tabuchi method that was in the Hubble project. We also tried the simplified SWU, which ended up being much less efficient because it needs like a isogenous curve, and the lowest degree was the 59-degree isogenous curve, which ends up being super gas intensive. Some further EVM optimizations we made to the scheme is that we use Keccak everywhere instead of SHA, which is cheaper in the EVM. And we use the modx precompile, where it's cheaper than an ad chain. So what's the state of BLS on BN254 now, as opposed to 2 years ago? Well, it's actually now implemented in drand, and there's a new network I mentioned before. It's called the evmnet beacon. And you can use this URL here if you can see it. I think it's big enough. You can get the info, like the public keys. The public key is a G2 public key. And if you have that on your contract, then you can go forth and verify BLS signatures, drand signatures in your contract. Warlock, which is another Oracle startup, they forked our BLS contract, and they got it audited by Zelic. So you can visit their fork there. I think they didn't find any vulnerabilities. They found some improvements to it. But yeah. There's now basic support for BLS signatures BLS signatures on BN254 in noble curves, which is really cool. However, it's pretty basic. You need to bring your own serialization, deserialization functions, and your own hash to curve function as well, which we are working on still. We are just waiting on noble curve, Paul Miller to release the new noble curves release. And then we can add that support into the drand client lib as well, so everybody can easily use this in their contracts. So now that we have BLS on BN254 and we have the evmnet beacon, that enables what we call Anyrand VRF. We call it Anyrand because, well, it's randomness on basically any EVM. It provides a coordinator for your contract that you can request from our coordinator. It's like Chainlink VRF. The coordinator automatically computes and commits to a future round number of the drand beacon based on the timestamp of when you'd like your randomness to be fulfilled. And we run a keeper off-chain that fulfills these requests based on the requests that come in. But what's important here is, as opposed to like Chainlink VRF and other incumbent VRFs, is that anyone can permissionlessly fulfill the request on the contract. So even if our keeper is down, or if we want to selectively censor you for some reason, you can actually just override that and fulfill it yourself, as long as you have access to the drand relayer. Yeah, so once the fulfiller fulfills the round signature on the Anyrand contract, it's verified using the EC pairing precompile, and then the randomness is derived as the catch-hack of that signature. And of course, all the commitments are checked, like the round signature matches what was in the request, etc. And then your contract receives randomness through the callback, just like Chainlink VRF. It's free open source software, so if you go to this GitHub link, you can see the contracts, you can deploy yourself. If you decide to launch a new rollup tonight, you can have VRF straight away, because thanks to drand. Just like to take a minute to thank the Randomoo team for the collaboration. It's been really fun. They've been really supportive. And thank you for coordinating all the League of Entropy stuff. Also like to give some acknowledgements to Liang CC and Killick for the prior cryptography work on BN224. And also to Scroll for believing in our vision and supporting us with some grants and spreading the word. You can see this is a screenshot from when me and Patrick was on the Scroll podcast. It was pretty fun. If you're interested to know more about Anyrand, you can check out our docs here. And again, it's open source software. And if you need VRF on your chain and you don't want to run it, you want us to run it, send us an email or find us on Twitter or come talk to me. And yeah, that's it. Questions maybe? Yes.
When you are on an arbitrary rollup, how do you know that? How do you measure the timestamp, and how do you know that the timestamp has not been manipulated, for example, by the sequence?
Yeah, this is a really good question. So the question was, if you're on a re-rollup, how do you know basically that the sequencer isn't messing with the timestamp? Well, that's actually you should do your own evaluation of that when you're on that rollup. That is something that you should evaluate. How centralized is it? Does the sequencer, can they just like do any timestamp they want? Is there some sort of like force inclusion mechanism that can that kind of like limits what kind of timestamp you can submit and stuff like that? So that's outside the scope of like kind of what we offer. Does that answer your question? Yeah. Cool. Thank you.